This is lesson 1 in unit 11, and we're exploring periodic data today. We're going to talk about periodic functions, noticing how a function repeats a pattern of y values. We're going to discuss what the cycle is all about. That's the complete pattern of the y values. We're going to talk about the period, which is the horizontal length of one cycle, and the amplitude, which is half the difference between the maximum and the minimum values of the function. Let's use this picture here as a way to label that vocabulary. First, you notice the cycle where we started with an intercept, a maximum, an intercept, a minimum, and an intercept. That would be the cycle, the complete pattern. Intercept, maximum, intercept, minimum, and then finishing with an intercept. So that's one cycle, where the period is the length from the beginning of the cycle to the end of the cycle. So the period in this case goes from 0 to 2 pi. That's the period. And then the amplitude is half of the distance between the maximum and the minimum. So our midline is the y-axis. That's our midline. That separates the top half and the bottom half. And this is the amplitude. And in this case, our amplitude is 1. Amplitude is always the absolute value of the high point or the low point here. Amplitude. In example 1, we want to look at each picture here and identify one complete cycle in 2 different ways. So the cycle in the A version could either start at 0 and stop at 4, or it could start at -3 and stop at +1. So there's 2 different ways, either from 0 to 4 or from -3 to 1. And there's other ways, but that's 2 different ways. So the period would be the displacement or the difference between the start and the stop. And 4 minus 0 or 1 minus -3 would give us a period of 4. In part B, again, you can see that a cycle is going to go from a maximum, an intercept, a minimum, an intercept, a maximum. So we could have one cycle starting at 0 and stopping at 3, or we could look from low point to low point and see that one cycle could begin at -1 and end at +2. So the period would be the displacement between those values, and that period would be 3. For example 2, we need to determine whether each function is or is not periodic. And if it is periodic, we want to find the period. So in this first example, the graph does climb with the pattern, but it's not periodic because the y values don't repeat themselves. It just increases with each step up. But in example B, it is a periodic function. One cycle would complete itself in 4 units, and that cycle would be a minimum, an intercept, a maximum, an intercept, and a minimum. In example 3, we want to find the amplitude of each function. So amplitude, we said, was the half of the distance between the maximum and the minimum. So half the distance between the max and the min. So we want to take the difference between the max and the min. The max is 1, the min is -2. So half of that distance between 1 and -2 would be 3. So half of 3 would be 1.5. That would be our amplitude. And that midline would occur at y equals -1/2. So we go 1.5 up and 1.5 down for the amplitude. In part B, our maximum is at 4 and the minimum would be at -2. So that entire distance would be a distance of 6. And half of that would be our amplitude of 3. So we want to take half of the full distance, and that's 3. So our amplitude is 3, and the midline would happen at about 1. So right in between there, there's our midline. And we go 3 up and 3 down. Then for example 4, a real-world connection, we know sound waves are produced by periodic changes in air pressure. And we want to sketch the graph of a sound wave who has a period of 4,000th of a second and an amplitude of 2. So looking over here at the x scale, if we let each one of these integers, 1, 2, 3, 4, if we let that x scale be 1/1000th of a second, let's explain that. So we're going to let the x-axis scale be 10th, 100th, 1,000th of a second. And we know that the period is 4,000th of a second. So we have to have a pattern of an intercept and a maximum and an intercept and a minimum and an intercept. So we have to finish in 4,000th of a second. So that would mean halfway in between would be another intercept, and then a maximum amplitude of 2 and a minimum amplitude of 2. So we would have a sound wave pattern, one cycle that looked like that. And if I switched colors, I could draw another cycle. So intercept, maximum, intercept, minimum, intercept at 8,000th of a second. So 2 complete cycles drawn there. Now in example 5, you might want to turn the video off and try it yourself. Similar to example 4, we have one cycle of a sound wave that occurs between 2,000th of a second and 8,000th of a second. If the maximum value of the function is 4 and the minimum value is -4, your job is to sketch 2 complete cycles of that graph. And again, I'm going to let the scale for the x-axis, where we have whole numbers there, we're going to let those represent that fractional portion of our time, that it's 0.001 of a second. And we want that pattern to repeat, and that pattern for the cycle was intercept, maximum, intercept, minimum, intercept. But we needed to start at 2,000th and stop at 8,000th. So we're going to start at 0.002 and stop at 0.008. They're going to be intercepts. In the middle, that would be at 5. Is that right? No, it would be at 4.5, wouldn't it? 2, 5, 6, 7, 8. No, 3. Oh, I didn't mark it right. That's my problem. Right there. That's wrong. Okay, so at 2 and 5 and 8. And then in between, we would have at 3.5, we have a maximum of 4. And 6, we'd have a minimum of 4. So I'm just making the assumption that the sound wave went up first and down second. And we're drawing 2 complete cycles. So I'm switching to red. And every 1.5, so 1.5, we're up again. And 1.5, we're at an intercept. And 1.5, we're at a minimum. And then 1.5, we're at an intercept. So 2 complete cycles of the behavior of the sound wave, but it started at 2,000th of a second. In example 6, we're going to answer the following. If a periodic function goes through 5 complete cycles in 4 minutes, what's the period of the function? Well, we got 5 cycles. 5 cycles every 4 minutes. So that's going to be 4/5 of a cycle per minute. And if you think that through, that would be 48 seconds would be 1 cycle if you divided up 4 minutes into seconds. In part B, the period of a periodic function is 8 seconds. How many cycles does it go through in 30 seconds? So you may need a calculator here. We got 30 seconds that it's running, but it takes 8 seconds for 1 cycle. So 30 divided by, or seconds divided by seconds is gone, and 8 divides 30, 3 3/4 times. So we get 3 3/4 cycles are completed in that 30-second interval. In part C, the amplitude of a periodic function is 2.5, and its minimum value is 0. What's the function's maximum value? Well, let's see, that's pretty easy. If you think about it graphically, we have a minimum value at 0 and a maximum value at 5 if 2.5 is our midline. So I'm thinking of it that way. If y is 2.5 and the amplitude is 2.5 to 0 and 2.5 to 5, then my maximum is at 5. And that curve would go something like, oh, I'm trying to erase. That curve would go something along the lines of, if we started down here, low, high, low, high, it would oscillate back and forth like that. So we'd go from 0 to 5, through the midline, back to 0, through the midline, back to 5. And that, my friends, is the end of lesson 1.